Good afternoon, Rajesh sir.
Yeah, very good afternoon.
So we'll begin the session at 3 o'clock.
No problem. Yeah, I think we have a few more minutes.
Yes, sir. And if you would like to check your PPT on screen, then we could proceed with that, sir.
Yes, let me check. I will try to share now. Can you see my shared screen?
Yes, sir. We could see that.
Actually, there is some option that I need to enable because I will play the video. So last time there was some audio issue.
Sir, I think you can give a check right now for the audio. You can just play
Yeah,
that video and see.
let me do some video and see. Yeah, so. Um, can you hear the sound? Can you hear the audio?
Sir, actually, it is not audible.
Um, last time we had a similar issue, but there is no way to choose the system audio through the Google Meet.
Sir, could you please check on the volume level of the system?
Yeah, I can
Uh,
check that.
I mean the volume bar that is shown on the PPT.
Let me check. Okay, I can increase that and let me see. What about now?
No, sir, actually, we are not able to hear. So, do we have any other video?
Yeah, I have a lot of videos. I can check one more video, right? Uh,
Sure, sir, let us do that.
can you hear this?
No, sir, we are not able to.
But last time, later, actually, initially it was like that, but I don't know how it automatically got fixed. Later, you were able to hear, if I am right, because I did not do anything with the Google Meet here on my screen, but it started working. So anyhow, even if there is no audio, I can explain what is going on in the video. So I think that should not be a problem.
Yes, sir, sure. Sometimes it might work with the slideshow mode.
Yes, yeah, maybe it is. Maybe can I check
Yes,
in a
sir.
slideshow mode? Let me check if it
Sure,
works.
sir, sure.
What about now?
Sorry, sir, we are not able to hear.
Okay, so I think I have to give a live commentary.
Good afternoon to all participants. We'll resume with the session soon. So the last session for the day would be handled by Dr. Rajesh Kannan Megalingam. He's a director at HUT Labs, Amrita School of Engineering, Kollam, Kerala, and he would be dealing with the topic entrepreneur opportunities in robotics and automation. Dr. Rajesh is an electronics engineer leading research on humanitarian technologies with special emphasis on robotics at HUT, that is Humanitarian Technology Labs, and professor at EC Department, Amrita School of Engineering, Amritapuri Campus, Kerala. He completed his undergraduate in engineering from College of Engineering under Anna University, Chennai in 1997 and Masters and PhD at Amrita Vishwa Vidyapeetham University in 2010 and 2015 respectively. His research areas include robotics, embedded systems, semiconductors, and healthcare. His research focuses on autonomous robots, vertical climbing robots, robots for rehabilitation, etc. He has 7.5 years of industry experience and more than 15 years of research experience. He has worked as VLSI design and verification engineer at various companies like ST Microelectronics, In Silicon Incorporation, etc. in Bay Area, California, USA for 6 years before joining Amrita University in 2004. Since then, he has published more than 160 research papers in reputed journals, international conferences, and book chapters. He has 11 patents applied and 1 approved. He is currently guiding 5 PhD students and several teams of bachelor students at HUT Labs. He is also actively engaged in teaching and guiding several teams of undergraduate students in research and competitions. He has won several awards, including the Award of Excellence twice from Amrita University, which is the highest award by the university, Best Paper Awards, Best Design Awards, etc. He is the recipient of the Global IEEE Undergraduate Teaching Award 2020. He is IEEE Student Branch Counselor, which has won several national and international recognitions, awards, project funding, etc., which includes the Outstanding Branch Counselor and Advisor Award from IEEE USA and Outstanding Branch Counselor Award from IEEE Kerala section. We welcome you, sir, to the session.
Thank you very much for the wonderful introduction. So, myself, Professor Rajesh Kannan Megalingam, professor in the Electronics and Communication Department. And also, I am leading the HUT Labs, which promotes a lot of research in undergraduate students. And in fact, the award that I received from IEEE, the Global Teaching Award, that is because of the promoting undergraduate research that is oriented towards humanitarian technologies. So today's topic is going to be entrepreneur opportunities in robotics and automation. Basically, I was a VLSI or a semiconductor engineer for about 8 years. And 6 years of my industry experience was at Bay Area, California. I was working in few semiconductor companies during that period, including ST Microelectronics. So basically, I was a chip designer. I completed my master's in VLSI only at Amrita after joining Amrita. But my PhD was more related to robotics. I was very much interested in hardware. So I have worked quite a lot of hardware, building entire system, like similar to a computer or robots and other stuff, particularly the electronic part of any system. So when my PhD thesis was oriented towards robotics, that is how I started into robotics. So in this almost 10 years of experience in robotics, I have started 2 companies, one in 2015 and 2 startups, I should say, and another one recently in 2020. So I have experience with startup. I have also industry experience. So I thought this topic would be relevant: entrepreneur opportunities in robotics and automation. Right. So I'll give some overview about the lab. Right. We focus on basically on robotics, and all the robots that we build here are oriented towards humanitarian technologies. In healthcare or human-aided devices or embedded system, whatever it is all related to helping people in the society. As I already mentioned, we strongly promote undergraduate research and encourage the undergraduate students to take part in humanitarian technology projects. Several significant projects came out of this, right? The first one is the Amaran, which is an unmanned robotic coconut tree climber and harvester. Second one is Mudra, hand gesture based powered wheelchair. Third one is Selfie, self-driving wheelchair. Fourth is Paripreksha, search and rescue robo in disaster management. Paricharya, service robo for elders. Suraksha, IoT-based crop protection system for farmers to protect their crops from wild animal attacks. Then finally, the COVID robo army. We developed 4 robots for the COVID cause. Robots for food and drug delivery, ultraviolet sanitizing robo, patient transportation system, and also public awareness robo. You can see that 600 plus undergraduate researchers till date at humanitarian technology labs. And currently in 2020, we have about 52 undergrad researchers. More than 160 research papers, as already in the introduction, it was mentioned this number. But what was not mentioned is that 95% of these papers came out of undergraduate research. And we also got about 50,000 worth of US dollars for funding from IEEE. All this funding is for undergraduate research. And finally, the 2 startups, one in 2015 and another in 2020. So these 2 startups are basically came out from this undergraduate research work. Right, so this is the current HUD Lab team, all right, who was like, now all of them are working online, still supporting for projects at HUD Labs. Right, so now coming back to the topic, if you take this topic, robotics and automation, all right, it's a $1 billion business opportunity, multi-billion-dollar in India particularly. Why? Because now when you consider building robo a decade back, 15 years back, when I joined Amrita, it was extremely tough. All right, why? Because the basic building components are very costly, and most of the sophisticated items required to build the robots have to come outside the country. All right, the people did not have that much money to procure all these and build robo. So if you look 10 years back, it was all only line following robo people were building, students were building. But the problem is even till late, 5 years before, till like maybe 2015, 2016, and even today, you can see workshops on line following robots, right? Whereas the countries, if you take the topmost robotic countries like Japan, Singapore, Malaysia, Korea, US, and the European countries, they are going far ahead, right, in developing the robotic technologies. We lag a lot. We lag maybe 2 decades. We lag compared to them. What they have achieved in robotics, we are lagging that much behind. But of late, these few years, I see a spurt in building robots, automation of the industry has started quite a lot. Right, so that happened 2-3 years, but still we are lagging. It's only few years, and I see a lot of startups, and that is a good sign because more and more students would be involved in getting experience building the robots. And also, they might want to take up or bring their own startup, which would again help India to develop in the robotics technology. So today, building robots became cheaper than ever, right? That is because of the hardware that is easily available, but still we are lagging in sophisticated robotics, advanced robotics, because these require some items which we don't have yet in our country. We don't fabricate, we don't manufacture them in our country, and exporting that, importing them from outside country is quite expensive. Right, but as I mentioned, building a robo is comparatively cheaper now. Now, smartphones have made the guts of robots less expensive and more effective than ever, because the electronics required for building a robo is there already in your smartphone. So your smartphone can be the heart of your robo doing many things. Right? 10 years back, you might know that these kind of smartphones were not available in India. Right, only in 2009, if I remember, I saw few of my students, final year students, buying what was called as smartphone, but not as the features currently we have today. So it is about a decade, right, since the smartphones came, and people became intelligent, right? They don't use smartphone just for calling people, right, or checking some things, but they also started using in the projects they are building. And new building blocks keep engineers from having to start from scratch. So whatever they want, they don't need to build from ABCD. There are already building blocks available in the market. They can put them together and build a robo in a lesser time compared to what was happening a decade back, because such building blocks were not available. And building prototypes of new hardware is easier than ever. Right, there are so much of open source available, including hardware. Right, for example, Arduino, Raspberry Pi. These are famous hardwares, open source hardwares. And there are so many other software tools that aid in hardware design. Right, EagleCAD, Tinkercad, so many other softwares. So it is easy to come up with a startup now compared to previous years. Now, these are some of the top robotics startup companies in India. All right, Asimo Robotics, I think that is in Kerala, where presently I am. They are into robotic simulation and control, machine vision, training, virtual reality, and navigation applications. So it's not only software they develop, they also build a lot of hardware for the software they are developing. Then Shastra Robotics, this startup builds and delivers robotic solutions for human-like automated functions, functional testing of real physical devices. Right, it is similar to pick and place, or you have a robotic arm, or then take a device and check it, something like that. Then Systemantics, this is actually an industrial robo startup, right? Industrial robo have to meet certain standards than the commercial robots available for the consumers. So to enable widespread adoption of flexible automation in industry, right? Particularly if you have a cloth export company, you need to pick up the stitched clothes. The robots can help to collect them. Right, then there is gray orange. They create robots for warehousing and automation space. They also design, manufacture, and deploy advanced robotic systems for automation. And then Mukunda Foods, they came up with the first robotic dosa making machine, right? So that is also possible, right? If you are thinking of something, there is a lot to explore in cooking, right? You might have heard about robots, right? Cooking what you want, the menu, it can have the menu, and if the essential items are supplied, they can prepare you a dinner before you reach home from work. Then Inventor Robotics, right? So they became famous with a 5 foot tall Mitra robo, it's like a friend robo, right? And it was displayed in 2017 Global Entrepreneurship Summit, which greeted our Prime Minister Narendra Modi. So it is basically designed for the service industry to interact with the customers and then get their feedback and guide them and stuff like that. There are many more companies, but due to some of the time constraint, I just restricted it to only the 6. Right. So now what we are going to do is that now this is the startup, the latest startup for the project. Basically, for 2 projects, our university technology-based incubator provided the seed funding for the startup. One project is Amaran, the robotic coconut tree climber and harvester, and another one is the powered wheelchair, the self-driving powered wheelchair. Now at Megara Robotics, again, it's whatever we develop, it's for humanity. And what we develop is on the areas of rehabilitation, agriculture, precision agriculture, healthcare, and these are the main focus areas. We also engage in a lot of internships for the students who have passed out, particularly targeting the student community, not professionals, to train them, to equip them with the latest technologies related to robotics. All right. So now what I'm going to do is that this is a kind of a case study, how we did this, how a student project, right, was able to make it up to come out with a startup. What do we do at Hut Labs? So that is what a few slides I'm going to focus. Right. So what do we do? How do we do? So this is the mentoring model we carry out in Hut Lab. Right. So this is first year what we do. Right. So at the end of the first semester, right, during their vacation, in the first semester, we would start up with some workshops, seminars, or project camps, which would be span of 2 weeks or 5 to 10, 5 days minimum, 10 days maximum, something like that. Now, at the end of this workshops or project camps, this is an extensive one, right? At this project camp, we have designed it with our experience in several years in this area. So we award them cash prize. We select top 3 teams or top 5 teams, top performing teams. We select who are all motivated, and we give them cash award. Right, the cash award is not direct cash distribution. Right, instead, it would be a reimbursement for some project that they are going to come up with. So what we do is we discuss a possible project with these teams. So you can see that we have conducted 85 workshops in the past 10 years for this kind of activities. And we have distributed about $5,000 for the students who were top performers during these camps. Now what we do is we go to the next one where we invite a mini project proposal, 3 months to 6 months of project during the second semester, and it is open to all, right? It is open to those who attended the project camps, those who did not attend the project camp, and it is not a particular department. It is open to all the department first year students, right? So what we do, we have a committee to select these projects and award cash for completing these projects. Right. So far, 120 teams have been selected for this project funding. About, you can see, $25,000 of cash we have given. Of course, that is a lot of support from our university. Right. So during the second semester, we select the project groups with the mini projects that they submitted. And during the summer vacation of the first year, we start the project training. We train them at least 50% of the vacation time, they have to be in-house to undergo this training. And they learn a lot. We teach them how to do the project. Like this is also a program designed in such a way that they learn many things to execute the project properly. And so far we have trained 51 teams. All right. And then finally what we do is we also start the research training. In the first year vacation itself, we teach them how to write a paper, a research paper, how to convert a project into a research work. So now we go to the second year. Right, so we start with the mini project. The students start working on the mini project during the second year and also start the research work. We encourage them to start writing the research papers even in the third semester. Right, according to our university policy, whichever paper anybody write has to go through a selection committee, and only with the approval we can submit to any conference. So you can see in the third semester we have about 50 plus research publications so far, and also hundreds of students have traveled outside the country to present their research work. That was the best opportunity in their life, right? Because when they go and present, they see, they learn a lot. They come across with so many things to take home, right? So they have traveled to several countries, including Singapore, Japan, Malaysia, all right, Vietnam, in Asia, also some Arabian countries, UAE, European countries like Austria, Germany, and even US 2 times. All right, so that is one of the best opportunities they get in their life. All right, so next is we train them in writing project proposal. I already mentioned we got about like more than 50,000 US dollars in funding, and that is because of this extensive training they undergo, right? So we teach them how to write a project proposal, and simultaneously we also prepare them for competitions. So by the end of the second year, right, they would have already finished their mini projects and they would be thinking about their major project. Right, the major project is supposed to be for 2 years of time approximately. Right, so we prepare them for competitions because that is one of the best platform to compare their work. Even if they go to attend conferences, right, they won't be able to do this. They won't be able to achieve much in this sense, where they can compare their work with others and know where exactly they are. Right. So many international competitions they have taken part. So 15 plus students teams have taken part in international competitions. Right. So they have been to European countries and also some Asian countries for the competition. Now, third year, right, as I mentioned, major humanitarian project is going to start. Along with that, they would also continue their research work, writing their paper. All right. And one more component that we introduce is the preparing them for higher studies. All right. So if their interest would already be decided by them, whether they want to take up higher studies or whether they want to opt for going job or whether they want to start their own company. The majority of the students at Hut Lab go for higher studies. Right? Not majority, right? If you say in the decision wise, majority students go for job, but at least a good number of students go for the higher studies. And only few would choose for the entrepreneurship role to take up to the startup. Right. So in the second year, you can see the number again 50 research papers approximately in the second year, and 100 students of the third year. Third year, and about 100 students have traveled for presenting their research work. And several, like more than 100 students have opted for the competitive exams. But these competitive exams that I mentioned is mostly going for masters outside India. Only very few opt for GATE. I don't know why. Many students don't prefer for GATE. All right, but most of them are comfortable with preparing for the competitions or the higher studies in America or European countries. And also third year, we also train them in writing journal papers. Right. So it's quite an exhaustive task, right? You might wonder, all right, these are all extra things, right? It's not part of their curriculum. But my experience is that they would be able to manage. They have managed very well so far for several years now. So I'm pretty much sure what was started as an experiment turned out to be a huge success. We were worried initially when we started like this in Hut Labs, university authorities have some concerns how they are going to manage. But the results showed that they were still able to have their academic record perfect and also able to achieve in all these things. So we train them in writing journal papers, and also they start submitting the proposals for funding. So so far 17 funded projects, right? All of them during third year, right? Because they are already experienced, they learned a lot, they know many things in doing a project. They are of all other things, they are very, very confident, right? Because students fear to take up hardware. Software somehow you can manage to get the output. But if your hardware doesn't work, you would lose your motivation. Students are very restless. They want the result so quickly. So if they don't get the result, they get dejected very easily. Right, so it is not easy to take up hardware, but because they have already worked, they are quite confident to submit for the proposals, and so far 17 funded projects in this 10, 11 years. And still people go for competitions even during the third year. Right. So in final year, it's continuation of all what they did in the previous years, particularly writing the research paper, conference or journal paper. But in the final year, they would have taken up the competitive exams, particularly GRE, TOEFL or IELTS, and they would start applying for masters or PhD. So in US alone, I have more than 65 students who were part of HUT labs during their bachelor's. They are all now working in like topmost companies like NVIDIA, Intel, TI, the Texas Instruments, Cisco. All right, these are some of the top companies. Qualcomm, right? And right, in journal wise, we can see that about 15 journal papers we have got from the undergraduate students. Right. So now we also have two startups. Well, the number two might look very small, but it is a big achievement in terms of bachelors starting a company out of their project, or a company being started out of the projects by the bachelor students. All right. So it might look right how research can contribute to startup, how training can contribute to startup. These are all small things that add up to their confidence. All right. That is very important. All right. We are not training them in a conventional way, in an entrepreneurship accelerator program or this or that. They have to be technically strong if they want to start their company. All right. Well, they have to get training how to run a company also. I'm not telling. First thing is they have to be a full grown engineer. Right. Only then they would be able to run very confidently. So this would help not only in startup, this would help in their career, in their higher studies, or whatever it is. So this is the model that we carry out at HUT Labs. Right. So now we will look at some of the wonderful projects that these students have come up with, and very modern. Right, the first one is about the unmanned robotic coconut tree climber and harvester. I would run the video. Right, let me see if you can hear. Can you hear the video? Do you hear the audio?
No, sir, we are not able to. I think, no, sir, we are not able to.
Okay, anyhow, so this is about the project because there is an acute shortage of the coconut tree climbers, right, in India.
90 million coconut trees and 50,000 trained climbers are required.
Can you hear?
Sir, we can hear it.
30,000
Okay.
trained climbers available according to the state economics and statistical department data. The situation is same in all states of India and most of the Southeast Asian countries that produce coconut. Currently, there are different mechanical climbers available in the market in which the user has to go up with the machine for harvesting. We propose Amaran, coconut tree climber, and harvester to solve this problem. Amaran consists of ground station, climber, and harvester, in which the ground station has a controlling device. The climber can be fastened to the tree with a spring mechanism. The climber is provided with a gate which can be removed by fastening the climber to the tree and then attach a gate. The circuit box attached to the gate consists of power management and control circuits required for Amaran. A Innova 60 ohm robotic arm with a customized electric cutter is used as the harvester. Using track motion, we are increasing the workspace of the harvester. Single 240-volt AC supply is required for the entire system.
So we have won several awards for this. We have several patents also, right? So we had one OMRG Asia Award in Singapore. Right. This recently we were the finalists in the Cisco Global Challenge 2020, both in international and national category. So we have 3 journal papers and 17 conference papers out of this project. And also this is one of the project that led to the second startup funding by the Amrita TBI. Okay, something happened. Okay, something happened. It got stuck. So I'm going to close the program and or restart the program.
Sure, sir. We'll wait.
Are you able to see my screen?
No, sir.
Okay, I'll share it again. Can you see it now?
Yes, sir. It's coming. Yes, sir.
Yeah.
It's visible.
Okay. Okay, so we will continue. So the next one is Mudra. This is the hand gesture based wheelchair. This is the first bachelor project. We got funding for the first startup in 2015. So let us go to the video. Can you hear the sound?
With disability in mind.
Yes, sir. It's audible.
Imagine how his life would be. It is impossible to lead a normal life. Such people are completely at the mercy of others.
Sorry.
Many systems, but many problems. Most of the power pages are joystick based, but not comfortable for all users. Hut Lab presents a novel solution, Mudra. Mudra means hand gesture.
So I will skip this because it's
Only one-fifth use the gesture pad called G-pad that we developed. Here, the user can show hand gestures by simply moving the hand over the smooth surface of G-pad. It is made with infrared sensors, so it is cost effective.
So we
The
have a
other option
patent.
is the Android app developed in our lab. This can be installed in any tablet or smartphone with Android OS. The users need not pay extra for this HCI. The user can place a finger or hand over the touchscreen and swipe as per the app GUI. A caretaker, either nurse at hospital or a relative at home, can also use this.
So actually, this feature was very helpful for us because now you can see that this wheelchair is controlled also not only by hand gesture by the user themselves. It can also be controlled by the caretaker. So this is one of the idea that we use for one of the COVID projects, right? Because the COVID patients need not come into contact with the caretaker if it's a nurse or a wheelchair pusher, so they can operate it at a safe distance from the patient, so that there is no direct contact between the patient and the caretaker.
A patient at hospital can be easily transported because of this feature. Patients at hospital or people who require wheelchair at airports can be easily transported without the need for physical pushing. It's not an end. It's an ongoing research process. Expect more.
So that is so we have one patent already filed for the gesture pad we developed. It's very low cost one. It requires only 5 pairs of IR transmitters and receivers. That is it. I can do the job of having the hand gesture captured. We were using earlier versions, sophisticated cameras and image processing algorithms, which introduce a significant delay because if you go for image processing algorithms to find the hand gesture, you need to spend some time. The algorithm requires some time to detect, right? So that was the problem. Now it not only we got away with the cameras and image processing algorithms, we also have a very cheaper solution for capturing the hand gesture. Right. So this one is the self-driving wheelchair. We call it as a navigational board. And this is also one of the projects that, along with the robotic coconut tree climber, the second startup was funding was given. Right. So this is like you don't need anything, right? You don't need a joystick. You don't need any other control equipment to control the wheelchair. Right. So what it does is it captures the map of the environment, and the map is loaded into your smartphone or any electronic gadget. And once the map is captured, you touch in the map where you go, the wheelchair will automatically take you. So this project was an inspiration from a 2013 visit. As I mentioned, a group of bachelor students and myself visited San Jose, California for a poster presentation which got accepted in an international conference, GSTC, IEEE conference. So we had an opportunity to visit the Google Museum at Santa Clara. I think it's Santa Clara. So there we saw the Google car, right? At that time, it was only few years after all this self-driving car became a very big hit, right? So that was an inspiration. So we thought we were already working on hand gesture-based wheelchair. So why can't we convert it into a self-driving one? So that was the inspiration here.
Life easier. But the technology can also be extended to wheelchairs for helping the people with mobility issues. The interest came out after investigating the people who depend on wheelchairs and wheelchair pushers to travel from one place to another in an airport. We realized that people with mobility issues face a lot of difficulties in their day-to-day travel and most of the times have to depend on a second person. Our self-driving wheelchair, Self-E, can change the way the society looks into the wheelchairs. Self-E system has three phases. In the first phase, the wheelchair is driven through the environment where it has to operate and creates a map of the environment. A similar map is created in the Android application that we developed, where the user can point to the destination that he or she decides to travel to. Once the destination is pointed through the app, Self-E wheelchair plans the shortest path and moves the wheelchair towards the destination. The hardware equipment we use consists of a single laser scanner. This laser scanner can identify the environment and also moving objects like we do. The onboard software automatically reroutes the path while avoiding any sudden obstacles in its path. Our self-driving wheelchair, Selfie, is fully operated using any Android-enabled device like smartphone or a tablet. The users have three different modes to operate Selfie: manual, auto, and fixed modes. The manual mode has easy access to the wheelchair with a simple direction interface where the user has to continuously navigate using the app. The fixed mode is used for navigating common places like shops in airports or rooms in hospitals where the destination is known in advance. In auto mode, the user can choose any destination on the provided map. The user has to just point to the desired location using the Android device and the wheelchair starts moving. Self-E can also navigate through tight spaces like passing through doors, corridors, and even getting into a lift. This autonomous technology can be used to deliver goods in industries, food in restaurants, people in airports, hospitals, at grocery shops, etc.
Yeah. So this is one of the products that we are aggressively working at the Megara Robotics to take it to the market. So currently it is in the production stage, and also testing is going on in parallel. So this one of the prototypes or the beta version of the product we have deployed in Amrita Institute of Medical Sciences for using with the patients. So last 3 months, every month, we were at the medical hospital for testing with the patients. All right. So that is the current situation of this one. So let us go to a few other things that happening in on the Hut Labs. All right. So this is the service robo. All right, and this is for the disaster management. All right. So let us see this short video before I give some explanation.
The speech recognition for the system is done by integrating the Android speech application to the IBM Watson chatbot, where the recognized data in the application is sent as a message data to the ROS master. IBM chatbot acts as an assistant for human-robot interaction. The mapping of the environment is done by Gmapping package. This is the map of our Hut Lab, which is divided into 4 different sections: Section 1, Section 2, Section 3, and Section 4. Navigation to the desired location is obtained by localizing to AMCL package and integrating it with move-based package. For object recognition with Connect sensor, we are using an algorithm called YOLO, where the robot needs to be trained with different images of objects. The robot can recognize the trained objects and also gives the object midpoint coordinates with respect to the origin of Kinect sensor for pick and place purpose. In case of a person, the robot can estimate characteristics like gender and age. Currently, we are using the 6 degree of freedom Quinoa arm for pick and place and for basic human-robot interaction. Here is an example of human-robot interaction where arm is used. We are currently developing a gripper to serve as an end effector for the arm to hold the objects.
All right, yeah. So this is one of the projects that went to the RoboCup German Open in 2019 at Germany. It's a place called Magdeburg under the service robo category. All right, so we were the only team from India to take part in this competition, and even though we did not win any prize, as I mentioned, the exposure and the experience and the networking, all these the students have got is priceless. So we have not dropped this project. All right, so we are continuing with this. Developing more on the algorithms, all right, to make it reach the people for which these are all being designed. So one other thing that we focus at AtLab is that even if a student team works on a project like this for 2 to 3 years, it is not enough to complete. Normally what happens if some of you are, I think many of you are in teaching profession, and if you have guided projects, the project is forgotten once the students graduate and leave. But we make sure that does not happen, particularly any significant project like this. We hunt for the next team of students who can continue with this project. All right. So, for example, we started the first wheelchair hand gesture project in 2010. And even today, we have not stopped the wheelchair project. It has gone through several revisions. All right. We have integrated several later advancement in technologies. We are still looking forward to improve that further. All right. So, similarly, all the other projects. All right, it's not like we worked on that on few years or just a final year and dropped. So that is one of the reasons we were confident to take it as part of startup, because we know in and out about all these things. It is just a matter of productization, because everything else is already done. Right? Because it's not a few months of work. We are stepping into a startup. Right? It's several years of work and experience that gave us the confidence to go to the next step of taking up the startup. Right. So this is the search and rescue robo. This went for the competition, German Open, 2 years, 2018 and 19. This was also part of the World Robo Summit in Japan, 2018. All right, so let us see about this one. So this was in Japan during the competition. And again, we were the only team from India for this competition. There were about 15 different countries. This is the latest version. You can see that it's very compact. So the operator cannot see the robot, so he will be in a cabin, right? And only through the camera. So this pulling out this pipe, it's not. He has to operate through the camera. Right, so this is about the search and rescue robot. Okay, so now we are going to see a set of robots, maybe only few videos I have for that, right? That we developed, I told, right? We also developed some robots for the COVID cause. And this is the food and drug delivery robot. It's a teleoperated one. I can take food, drugs, drinks to the patient in isolation wards. And another application we found out that was it can also be used in restaurants to serve food for people, and it can be very, very useful, like during the current COVID situation. Annapurna is a teleoperated robot developed at Humanitarian Technology Labs, Department of Electronics and Communication Engineering at Amartya Vishwavidya This robot can be remotely operated by the operator or the nurse to serve food, drinks, and medicine to the patients in the isolation wards. This way, the nurse or the operator need not come in direct contact with the patients in the isolation wards. This robot can be built and assembled within few weeks, and it comes at a very cheaper rate of less than 25,000 rupees. So this also has a telemedicine facility. So if the doctor wants to interact with the patient remotely, the doctor would be able to do that. And this is one of the most wanted product or project, right? Because this ultraviolet sanitizing robot, this can be used for sanitizing rooms particularly, right? Like for example, if the COVID patients, they get discharged, the entire room has to be disinfected. Currently, they use a lot of several liters of sanitizing agent to sanitize the entire room, right? So now we came up with this robot, that can disinfect this entire room, right? If this robot is so powerful that several cubic space it can disinfect very short time. This can also be used to disinfect toilets and other stuff, right? That is also possible. So currently this is being used at Amrita Institute of Medical Sciences for disinfecting all the patients' wards and hospital rooms. This is also being used at our university. Our university, right? You might know every university is planning to reopen, so they are using this to disinfect all the hostel rooms and also the office area. So we find that this is one of the most useful robots that in the current situation being used in many places. Prabha is an ultraviolet disinfectant robot which can be remotely operated and controlled. This robot has 3 powerful ultraviolet lamps at 55 watts and can disinfect a room of 12 feet by 12 feet within less than an hour. This also has an upgraded version which can have 6 lamps at 55 watts each lamp and can disinfect the room of 12 feet by 12 feet within less than 30 minutes. Because it's remotely operated, there is no need for the person or the operator to come into direct contact with the ultraviolet radiations which are harmful to eyes and skin. Okay, I think we have come to the end of the videos. So let us see what we have next. Right, so this is the IoT-based crop protection system. Right, so this is a huge problem in India where the farmers incur a huge loss every year because of the animal attacks. The animal attacks are not the same everywhere because there are different animals in different states that cause this damage. For example, in Andhra Pradesh, where we deployed this project, it was wild boars. But in central India, it was a type of deers called nilgai deers. And in some places, it is monkeys. And in some places, it is some other type of deers, rodents. But in most of the places, a common one is elephants. Right? And also, it depends on whether your field is close to animal reserve area, which climatic conditions, what type of crops you grow, which attract these animals, many factors we have researched and found out. This was one of the project funded by the IEEE site, a special interest group in humanitarian technologies. This project is deployed in Sitarampur village in Andhra Pradesh. Right. So you can see in this photo, people use clothes as fence to protect the crops from animals. The area is mostly paddy and this what you call urad dal, right? So they grow a lot, these 2 items. These 2 items attract wild boars a lot in huge numbers. When they come in a gang, they come in a group, and they don't just eat what they want, right? But that is not what they do, right? They just destroy, they just play in the field and destroy the crops, right? So that is a huge loss for the farmers. So we came up with an electronic fence using laser, right? So whenever the animals cross this laser beam, right, we trigger an alarm, right, with a huge sound, and also we trigger powerful lights. So with the lights and the sound, the wild boars are scared away. All right. But this solution might not work for elephant, right? Because we need a separate kind of setup to scare them away. But for current scenario, which are wild boars, we use this kind of setup, and it is solar powered, right? You can see we have installed a solar panel there, right? So for several acres or several fields of this fences, one solar power panel is more than sufficient, because this does not consume a lot of power, as it is not continuously switched on. It is going to get triggered, and even that only for few minutes, not too long. So this one solar panel can supply power to several fences, and that is why it is also cost effective. So the farmers need not spend too much on this setup also. So that is, now somebody had approached us for helping us to make it as a product, right? So that is, we are having a meeting this week to discuss about the possibility of making this as a product. So that is about this one, right? So this awards and recognitions, right? I might have already mentioned. Right, Amaran that is the robotic coconut tree climber, got the finalist in the Cisco Global Challenge 2020. Right, and Hut Lab, you can see we are several firsts. Right, unmanned robotic coconut tree climber and harvester, self-driving wheelchair, the IoT-based crop protection system for scaring away the wild boars. Right, so this project, particularly the Amaran, was launched in December 2016 during the international conference Raha 2016 at our campus. And the gesture-based wheelchair, I told that we started working in the wheelchair as early as 2010. Right, so we won the gold medal from Intel for that project in 2010. We also won other like best paper awards, best demo awards, and all. So 11 patents, right? By the time this is a mistake. So far 11 patents filed, and one is approved. Right. So the 3 more patents latently filed lately for the COVID projects. So the count is 11. Right. So students have also won several other competitions like Intel India Embedded Challenge, Yahoo Accenture Innovation Jockeys, then 3 times from Mentor Graphics University Design Contest, then a student poster contest at the IEEE Global Humanitarian Technology Conference, Washington, USA. Again, USA, we got a Best Paper Award or the Poster Award. There are 5 Best Research Paper Awards we have won from all these projects. And you can also see the students have won 8 IEEE Richard E. Merwin Scholarship Awards from the IEEE. Right, so these are some of the photographs students winning. There are too many, like I'm not putting so many things. This is during the conference participation, right, in so many places. So as I mentioned, right, there are so many awards that we won for the robots. Right, we won 5 awards, 5 prizes in the OMRG, One Moment Robo Glory contest in 2015, held at NTU Singapore. So these are some of the list of the 5 prizes that we won, and 4 prizes we won in 2016 robotic contest. So we also took, as I mentioned, we already were in final rounds for 3 projects. In the disaster management category and service robo category of RoboCup German Open, and took part consecutively in 2018 and 2019. We were about to go participate in 2020 contest also, but thanks to COVID, right, we were not able to go. Right, and one more information I forgot to mention. Right, we were part of the WRS World Robo Summit. Right, at Tokyo. Right, but the same World Robo Summit have chosen both the projects, the service robo and the search and rescue robo, for the 2021 contest. So two teams are working towards that to attend this in 2021. Right. Apart from that, there are also two teams of students took part in RoboCon 2018 and RoboCon 2019. They could not take part in 2020 because of COVID. And both the years, the students won first prize in these competitions. Remember, all these are international competitions. In 2018, it was in Tokyo Tech University, Japan, and in 2019, it was in MIT, USA, Massachusetts Institute of Technology. Right, currently we are working, a 31-member team is working on the autonomous car for the Indy Autonomous Challenge 2021, the world's first head-to-head high-speed autonomous race at the famed Indianapolis Motor Speedway. Right, so these are some of the photos. Students, you already saw some videos where students were taking part in all these things. So this is 2019. Both this is the service robo you see here, and this is the search and rescue robo. Right, this is RoboCon. Right, several countries. It's an invite-only competition, and they invite only one university from each country. Right, so this is going on for 31 years without India being part of that, and we got the opportunity first time in 2018, and they selected only Amrita Vishwavidyapitham University out of all the universities in India, including IITs. Right, so we will also take part in 2021. So we are discussing about that. 2020 already cancelled. So these are all like, this is RoboCon 2019. Right, I already spoke about the master's program, and this internship is something new. So 65 students, you can see they were part of Georgia Tech, Columbia University, UCA, Los Angeles, Las Vegas, University of Cincinnati, University of Dallas, NCSU, University of, so top, almost many top universities, they got masters. They are working in top companies in the world. And they also come back and contribute. That is the sweetest part, right? They mentor their juniors. They contribute in terms of offering them training, offering them as a project guide, to be a project guide, conducting seminars, webinars, make sure that they visit HutLab and share their experiences. Right, some of them even help with some of the design in the research work we carry out at HutLabs. Right, and internship is one good thing that we promote among the students at HutLab. About 70 students have got internship opportunities. Mostly they went to Singapore, Hong Kong. Sometimes they were in Europe also. Right, so that is a good thing. So when they go for internship, they also make sure that they explore the possibility of getting into masters in those universities. So alumni, as I meant, we make sure that we meet quite often. When I travel, they come and meet, or when they come to India, they come, make sure that they come here and share their experiences. Right. So now coming back to Megara Robotics. Right. So we were the finalists in the Cisco Global Challenge 2020 for the robotic coconut tree climber in both the global and the India categories. And we also got the most promising startup award from Atmanirbhar India Artificial Intelligence Challenge 2020. That is by the government of India. And also Megara Robotics featured as Tech 30 startup by Your Story at XParks 2020. Right. So when you want to build your own startup, right, some of the do's and the don'ts, right? So don't rush to build your robots, right? Because it is a costly affair. You look at you saw all the videos. It's not few thousands of rupees we have invested in these robots. For example, the robotic coconut tree climber, we have invested more than 1 crore of rupees so far. We are working on that for 7 years now, right? So it's a costly affair. If you want a startup and if you look for a early product in hardware, you have to be very careful because you might lose your money because the outcome might not be as expected. In case of software, you can always find a patch for the errors, right? But in case of hardware, if there is some problem with some fabrication or any wire or anything, you might have to throw the entire stuff. If the entire stuff becomes garbage, you won't be able to salvage anything good out of that, right? Do engage with your customer early, right? They might be able to provide you a good feedback. You might know what they exactly want. The customer might already have some experience with some product which they might want to share with you, which would be a very good input for you. Don't rely on clever design as a differentiator. The third point, right? It might be a very hi-fi design. Nobody had designed like that with so many features and other stuff. Finally, if the customer does not like, right, then what will happen to the robo, right? There won't be any taker for such a hi-fi stuff. So that is why the customer interaction, say for example, you are developing a robo for Amazon, right? Amazon has warehouses, right? And you are developing some robo. It is very important that you talk to Amazon on a daily basis, get their input, interact with them, and incorporate all the suggestions in the robo, right? That is what is very important, right? I think there is a power cut, right? Okay, so the fourth one is do understand the economics of the target customer and business, right? What does it mean, right? Your product should be affordable. It depends on the country where you are. For example, in India, if you are developing a robo, the customer are very price conscious, right? Well, they want a good quality also, right? They don't want to compromise too much on quality, but they are ready to compromise to some level on quality. But when it comes to cost, you know, you are also a customer in India and you would have access many online purchase systems like Amazon or Flipkart. And the first thing that you look for is the price, right? I'm pretty much sure most of you would sort the items in terms of price, right? So when you are developing a product in India, this is an important factor to do the business. You cannot have a very good robo and price it at several lakhs of rupees. Nobody would be interested in buying. Right? Don't go at it alone. Get to know your ecosystem. If you are a startup, you need to build a network among other startups, other companies. It is always good to maintain a good relationship with other companies. Maybe they are competitors. Fine, you don't need to talk to your competitor, but there are many other people in the industry. For example, if you are building a robo for Amazon, definitely Amazon is not your competitor. If you are building a robo for some warehouse or somebody else, some other company, some industry, right? Know the ecosystem, know about them well. All right. So what is happening? What is you take them along with you for the success of your startup. Right. So these are some of the 5 do's and don'ts. I think we almost I am done with the presentation. So that is it for today. So if you have any questions, now I would like to take up. We have 7 more minutes, so we can discuss few questions.
Thank you so much, sir. Participants, you can post your queries in the chat box, or you can unmute and ask it for yourself. Any questions from the participant side?
Okay, I think there are no questions. So
Yes, sir.
yeah, so I would like to take this opportunity to thank the toch Institute and Professor Deepa for giving me this opportunity to be part of this wonderful event. And I also thank on behalf of our Amrita Vishwa Vidyapeetham University and also the Humanitarian Technology Labs. Thank you very much.
Thank you, sir.
Thank you so much, Rajesh sir. Your presentation epitomized every good in entrepreneurship, and I'm sure the participants would have certainly benefited from your breadth of knowledge and depth of expertise. On behalf of the Department of Electronics and Test, I thank you once again, sir, for a truly memorable evening.
Thank you very much. Thank you all.
Dear participants, we are winding up the session for today. Tomorrow's session would be starting at sharp 10 o'clock. And one more information has to be passed. That is, all participants are expected to discuss with their own team members and finalize a topic for the project work that we had assigned yesterday. A Google form will be given tomorrow to enter your own topic. Thank you so much and have a great evening.